Here we are discussing on the pedigree. It is included in the practical classes of first semester MSc. The pedigree, what is the need of pedigree for the genetical study? At first, we should discuss on the usefulness of the pedigree analysis. In the genetical study, commonly we observe that Mendelian principle is based on the A plus B whole square, and algebraically it is explanation and expression of these algebraic equations, where A represents dominant character and B represents recessive character. Alternatively, it is mentioned as A plus A whole square. Suppose we explain the monohybrid cross of Mendel, and here it is AA plus 2AA plus AA. It is the outcome of Mendelian monohybrid panel. But in the human being particularly, the genetic analysis is not based primarily on this principle, but it inherits and lies by the term in the term of pedigree. For the pedigree analysis, at first it is necessary to observe and to know the symbols, because the pedigree is symbolically represented. And here some symbols are mentioned on the board, and these symbols are commonly used in the representation of the pedigree. At first, this one is the circle. The circle represents female. The circle represents female. The square represents male. If the circle and square is connected by a single line, it represents couple. It represents couple. And if the circle and the square are connected by double line, then it represents couple between close relatives. That is contiguous marriage. In the term of science, it is referred as contiguous marriage. The couple of between close relatives. If we observe this one, it represents a tree-like structure, and each horizontal line represents one generation. This is the first generation. It represents first generation. It is the parental unit. If the circle or a square is crossed, that means it represents the death of male or female progeny. Likely, here, if we observe this type of symbol, that a common root and root is in branch between two, it represents heterozygotic twin. And if the branching is originated from the horizontal line, it represents homozygotic twin. If it is a square or diagonal structure is observed in the pedigree chart, it represents intersex. That means the individual is not differentiated in male or in female. If the circle, any number is represented within the circle, it represents the number of girl child or the number of boy child. If the square is completely black or the square is completely black, it represents the diseased condition or the person is affected by trait we consider under a study. Here, the square and circle is represented by arrow mark. That means the pedigree analysis is initiated from that particular point. That is represented by the arrow mark. If the square or circle is half shaded, that means it represents carrier of the particular trait. If here a dotted, a small spherical structure is present in any pedigree tree or a step, it represents a stillbirth or abortion. And if a dot is present in circle, it represents that the woman is carrier for X chromosome. Then, by the use of the following structures, by the use of the following symbols, we analyze the inheritance pattern of any trait. That means the trait if we study the trait, that means in human chromosome is divided into two broader groups, autosome and sex chromosome. The trait present on the autosome is referred as autosomal trait, and the trait present on sex chromosome is referred as sex chromosome. Here, the autosomal traits if the trait is autosomal, it may be dominant or it may be recessive. Likely, in the sex chromosome, in man, the sex chromosome is divided into X chromosome and Y chromosome. In X chromosome, the sex chromosome either contains the dominant trait or the recessive trait. Again, and some characters and some traits are present on the Y chromosome. That means the X-linked character and Y-linked characters. Now, there are possibility for the pedigree analysis are broadly divided into four parts. First, the autosomal dominant pedigree for the autosomal dominant character, pedigree for the autosomal recessive character, pedigree for the X-linked dominant character, pedigree for the X-linked recessive character, and pedigree for the Y-linked character. Then we again write here first autosomal dominant, second autosomal recessive, third X linked dominant, fourth AX linked recessive, fifth Y linked. These are the four patterns observed commonly during the pedigree analysis, and each pattern has some characteristics, and on the basis of the particular characteristics we can analyze the inheritance nature pattern, and we can predict the appearance of a particular character in progeny. That means the pedigree is used either for the analysis of the inheritance pattern of the any trait, or it can be used for the genetic counseling of any couple having record of or history of any genetical disease in either of parent. But here we will discuss on each nature point-wise. But before going to these 4 or 5 patterns, it is necessary to know some specific principles of the inheritance, because the pattern of inheritance and fundamental knowledge of the probability both are necessary for the analysis and study of the pedigree. Here the two forms. One form is criss-cross inheritance. Criss-cross inheritance, and second one is skip generation inheritance. Third one is voluntary inheritance. These are the patterns, and before coming on the analysis of the pedigree, it is necessary to know these patterns. First, criss-cross inheritance. Here, the criss-cross inheritance clearly represents that in generation, the character of male is appeared in the character of female, or the character of female is appeared in the male. That means this one and this one. If the character appeared in opposite set of next generation, it is referred as crisscross inheritance. In again next generation, the possibility of the appearance of the character, this one moves in this one and this one moves in this one. Likely a crisscross like inheritance pattern is observed, and if any trait represents such type of inheritance, it is referred as crisscross inheritance. Second one is escape generation. Second one is escape generation inheritance, and in the escape generation inheritance, the character of parental generation is not observed in the next generation, but in grand population. Here, one generation is escaped. Of course, the allele is present, but it is not observed in a population, and again appeared in the next generation. Again from the grand generation, it passes to the next grand generation. In this way, one generation is always escaped. There is chance of the escapee, and if the character is escaped, it represents that the inheritance pattern is escape generation inheritance. Here, suppose, for example, a male or a father is suffering from hemophilia, married to a normal female, and here the possibility, here the checkerboard is not important to analyze, but here always the gametic nature of the mother is same nature and always contains the normal exposure. Here the chromosome is always normal, there is no chance of the disease. But here the father, the gamete formed from the father contains a chromosome, has hemophilic nature or hemophilic character, the gene responsible for the hemophilia, and another is the gamete contains the Y chromosome. Here, it is basic rule that the chromosome, X chromosome of the father, X chromosome of father is always transferred to daughter. It is the basic rule. the father is always X chromosome of father, X chromosome of father is always transferred to the daughter, and X chromosome of son X chromosome of son always comes from mother. Comes from mother. So, in this condition, there is no chance of the appearance of disease or the particular trait in first generation, but there is chance of the appearance of the disease in the grand generation. In this case, the one generation is escaped from the representation of the particular trait, and in this condition, it is referred as escape generation inheritance. Suppose in another example, suppose a autosomal recessive condition, a autosomal recessive condition. Here Here, suppose the autosomal recessive is always chance to represent in 25% population if the next generation is crossed. In grand generation.